My name is David Beneš, and for my study project I chose to talk about evolution of Tesla Autopilot and full self-driving system. I chose this product because it's a combination of a robot, computer vision and a machine learning. And it's not just a prototype in a lab, it's a machine that performs in real life. I do not have a Tesla, so I can only speak about what I have found online. So Tesla Autopilot and full self-driving has evolved from a basic driving assistance features in 2014 to an advanced neural network-based system that is it today. It shifted from a combination of sensors like radar and cameras to a pure computer vision and machine learning AI system trained on real-world data. Tesla started its autopilot development through partnership with company Mobileye in 2014. Back then they were using a IQ3 processor in combination with radar, ultrasonic sensors and a camera. In October 2015, beta version of Autopilot was released with features like traffic-aware cruise control, lane keeping on highways and collision warning. Cooperation with Mobileye ended in July 2016 when Tesla decided to train neural network and focus on a camera-based system only. At that time, they accumulated over 200 million miles of data. In October 2016, Tesla transitioned to in-house development of its hardware. They added automatic lane changes, auto parking and remote summon. Company also started to offer FSD with promised urban navigation and traffic light readings. Tesla updated its software over the year. This system still needed heavy driver supervision. The cars were equipped with 8 cameras for 360-degree vision and recording driving scenarios for neural network training. This differentiated Tesla from its competitors and underscored their computer vision. Tesla also announced their plans for a robotaxi car in the future. At this time, Autopilot shifted from basic assistance to AI-powered self-driving supported by in-house developed hardware. In 2020, Tesla started limited release of FSD for selected owners in North America. Transitioned to vision only and eliminated radar and ultrasonic sensors from their vehicles. From 2022 to 2023, FSD expanded to wider North American user base, added features like path planning, and moved more and more to rely on AI trained on video datasets rather than a modular code. So all this AI and neural networks need to be powered by some hardware. So in 2014, still with cooperation with Mobileye radar and sensors powered by IQ3 chip for image recognition and fusion of data from different sensors, Tesla was using so-called Hardware 1. This hardware was basically useful only on highways with clear markings and consistent traffic flow. As Tesla moved to its in-house development platform, Hardware 2 was introduced in October 2016. It used NVIDIA Drive PX2 platform customized for neural network processing. This system had 8 cameras for 360-degree vision, but it still cooperated with radar and sonic sensors. Hardware 3 was introduced in 2019, marked another step towards full autonomy. It contains 2 custom-designed processors delivering combined 144 tera operations per second for AR operations like object detection and path planning. To support vision-based approach, it processed up to 2300 frames per second. Next in line was hardware number 4, with improved sensor resolution up to 5 megapixels and computational capacity approximately 3-4 times higher than hardware number 3. Also eliminated radar and sensors and went full AI-powered computer vision. This approach was criticized by some as limiting in bad weather, which Tesla addressed in the next hardware iteration, hardware number 5. Once again, it got a higher compute power up to 8 times from hardware 4 estimated 2000 trillion operations per second. The cameras got automated sprays for clear visibility in adverse weather. This higher compute power brought more safety through learning models trained on bigger datasets. All these developments underscore philosophy that cameras augmented by neural networks can deliver better and safer results than a combination of different types of sensors. Training happened via supervised learning on video and telemetry from Tesla's fleet and simulations. That should deliver improved performance in unstructured environment. So for training its neural networks, Tesla built so-called Dojo supercomputer. It developed its own D1 chip optimized for the video decoding and matrix multiplications. This supercomputer collects datasets exceeding billions of miles annually, logging prediction errors, near misses, and environmental variations. Dojo efficiency targeted faster training cycles compared to GPU clusters. However, in August 2025, Tesla disbanded this project and redirected resources to commercial hardware from NVIDIA, AMD, and others for AI training. So FSD still needs driver supervision even today. Transfer to full unsupervised driving depends on validation processes. By mid-2025, Tesla unveiled plans for unsupervised full self-driving in selected locations in USA, specifically in Texas and California. Evidence so far shows the technology is not ready yet, evidenced by ongoing NHTSA investigations. In the future, Tesla plans to unveil Cybercab, dedicated two-passenger robotaxi without steering wheel or pedals with estimated cost under $30,000 per unit. Deployment plans target initial unsupervised pilot in Austin, Texas in 2026. In the future, it should be able to produce millions of autonomous vehicles per year. One of Tesla's visions for future is also ability of self-driving cars to bring some income to their owners by providing ride services. Another Tesla plans for the future is a fleet of autonomous semi-trucks once full self-driving system will be developed. So pros and cons. So definitely positives for full self-driving is safety, as even today the numbers show that self-driving cars are logging less accidents and crashes than human-driven cars, even though in the news we are focusing on the self-driving cars accidents, but in the big picture the numbers show that self-driving is much safer. The other pro or positive is of course driver's comfort. Even though I really like driving, I can imagine when I'm older or on the long hauls, it will be really nice to be able to take your eyes off the road and just relax. For negatives, there is definitely potential for job losses, as autonomous fleets will take over cab drivers, truck drivers, so that for sure will have like impact on society. I think that another negative is that people might just forget how to drive. And then there are of course ethical concerns. Let's say in situation when there will be crash imminent and the system will have to decide if, let's say, kill the driver or 10 pedestrians on the sidewalk, how will the system decide and who will program it? And of course there is like a lot of ethical questions around this issue that I honestly don't know how to answer, so that's definitely something for the future and for a bigger debate. Alright, that's all from me, and that's my independent study project about Tesla full self-driving system. Last page are just links with resources. Bye.